Colonel Takeshi Yamada stood atop the ridge overlooking the Salween River Gorge in Burma on March 15, 1944, surveying what he believed to be an impregnable defensive position. The river churned 200 feet below, carving through rock walls that had taken millions of years to form. Japanese engineers had demolished every bridge for 50 miles in either direction, and Yamada's intelligence reports confirmed that the nearest Allied engineering equipment capable of spanning such a chasm was still in India, requiring months to transport and assemble. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. He turned to his staff officers with barely concealed satisfaction. The Americans and their Chinese allies would break themselves against this natural fortress, just as countless other Allied offensives had shattered against prepared Japanese defenses throughout the theater. What Colonel Yamada could not have imagined as he gazed confidently across that gorge was that within 72 hours, American combat engineers would accomplish what he had calculated to be logistically impossible, using a revolutionary technology that Japanese military planners had never even considered existed. The confidence radiating from Colonel Yamada and his fellow officers that March morning was not the product of blind optimism or nationalist fervor. It was built upon 3 years of successful defensive operations across Burma and the bitter lessons the Imperial Japanese Army had taught Allied forces attempting to breach their fortified positions. Since early 1942, Japanese forces had demonstrated a mastery of defensive warfare in the challenging terrain of Southeast Asia that had frustrated every Allied attempt to regain the initiative. Major General Shinichi Tanaka, commanding the 18th Division responsible for the Salween River sector, had personally overseen the defensive preparations. His engineering officers had spent 6 months fortifying the eastern bank with interconnected bunker systems, carefully sighted artillery positions, and overlapping fields of fire that would turn any river crossing into a slaughter. The Japanese had studied every historical river crossing operation from the Romans to the Great War, and they had designed their defenses to exploit every lesson learned across 2 millennia of military history. The Salween River itself seemed to conspire with the Japanese defenders. During the spring monsoon season, the river became a raging torrent that could sweep away anything attempting to cross its width. Even during the dry season, the current remained treacherous, and the gorge's sheer walls meant that any bridge would need to span nearly 400 feet without intermediate supports. Japanese military engineers, consulting with civilian bridge construction experts from Tokyo University, had calculated that such a span would require at least 2 months to construct using conventional methods, assuming the defenders allowed such construction to proceed unmolested. Intelligence reports compiled by Lieutenant Colonel Hiroshi Matsumoto, Tanaka's chief intelligence officer, painted a reassuring picture of Allied engineering capabilities. The British had attempted several river crossings during their retreat from Burma in 1942, and all had ended in disaster when Japanese artillery destroyed their pontoon bridges. American engineering units, according to captured documents and interrogated prisoners, relied primarily on heavy Bailey Bridge components that required substantial time to assemble and could not be easily transported through Burma's primitive road network. At a staff conference held in the bunker complex overlooking the river on March 10th, General Tanaka had addressed his subordinate commanders with characteristic confidence. "The geography works in our favor," he had explained, gesturing to a detailed topographical map. "The Salween Gorge is deeper and wider than any obstacle the Americans have encountered in this theater. Their engineering doctrine is based on European conditions, where roads are good and terrain is relatively gentle. Here, they face an entirely different challenge, one for which they are unprepared both materially and psychologically." Captain Kenji Watanabe, commander of the bunker line directly overlooking the primary crossing site, had raised a question about the possibility of aerial bridge construction or airborne operations. General Tanaka had dismissed these concerns with barely concealed contempt. The Americans lack the airlift capacity for a significant airborne operation in this sector, he had stated flatly. As for aerial bridge construction, such technology does not exist. We have consulted with our own aviation engineers, and they confirmed that no aircraft in the American inventory could transport bridge components of the required size and weight. The assembled officers had nodded their agreement. After all, Japanese military intelligence was renowned for its thoroughness, and the assessments provided by Tokyo seemed unassailable. The Imperial Japanese Army had pioneered the use of light infantry tactics in jungle warfare, had developed innovative defensive techniques for fortified positions, and had demonstrated superior understanding of logistics in challenging terrain. If Japanese experts said the Americans lacked the capability to bridge the Salween quickly, then surely it must be true. This supreme confidence extended beyond purely military considerations. The Japanese command structure in Burma operated under assumptions about American character and industrial capabilities that were shaped by years of propaganda and selective intelligence reporting. American soldiers were portrayed as soft and overly reliant on material comforts, unwilling to endure the hardships that Japanese troops accepted as routine. American engineering was characterized as ponderous and inflexible, capable of impressive achievements given unlimited time and resources, but unable to improvise or adapt to unexpected challenges. Colonel Yamada himself had served as an observer with German forces on the Eastern Front in 1941 and had returned with reinforced convictions about Axis tactical and technical superiority. The Germans, he frequently told his staff, have shown that proper defensive positions can bleed attacking forces white regardless of numerical or material advantages. The Soviets throw masses of men and equipment against prepared defenses and achieve nothing but astronomical casualties. The Americans, even softer than the Soviets, will fare no better against positions we have spent months perfecting. The defensive system protecting the Salween crossing represented the culmination of Japanese defensive doctrine as it had evolved through years of warfare in China and Southeast Asia. The bunkers were constructed from reinforced concrete with walls 3 feet thick, capable of withstanding direct hits from anything short of heavy naval artillery. Each bunker contained sleeping quarters, ammunition storage, food supplies, and water sufficient for 2 weeks of sustained combat. Ventilation systems allowed the defenders to seal the bunkers against gas attacks while maintaining breathable air. Firing ports were designed to provide overlapping fields of fire while minimizing exposure to counter-battery fire. Behind this first line of bunkers, Japanese engineers had constructed 3 additional defensive lines, each positioned to command the terrain and provide mutual support. Artillery positions were carefully camouflaged and included pre-surveyed firing coordinates for every possible approach route. The Japanese had studied every historical river crossing operation from the Romans to the Great War, and they had designed their defenses to exploit every lesson learned across 2 millennia of military history. The Salween River itself seemed to conspire with the Japanese defenders. During the spring monsoon season, the river became a raging torrent that could sweep away anything attempting to cross its width. Even during the dry season, the current remained treacherous, and the gorge's sheer walls meant that any bridge would need to span nearly 400 feet without intermediate supports. Japanese military engineers, consulting with civilian bridge construction experts from Tokyo University, had calculated that such a span would require at least 2 months to construct using conventional methods, assuming the defenders allowed such construction to proceed unmolested. Intelligence reports compiled by Lieutenant Colonel Hiroshi Matsumoto, Tanaka's chief intelligence officer, painted a reassuring picture of Allied engineering capabilities. The British had attempted several river crossings during their retreat from Burma in 1942, and all had ended in disaster when Japanese artillery destroyed their pontoon bridges. American engineering units, according to captured documents and interrogated prisoners, relied primarily on heavy Bailey Bridge components that required substantial time to assemble and could not be easily transported through Burma's primitive road network. At a staff conference held in the bunker complex overlooking the river on March 10th, General Tanaka had addressed his subordinate commanders with characteristic confidence. "The geography works in our favor," he had explained, gesturing to a detailed topographical map. The Salween Gorge is deeper and wider than any obstacle the Americans have encountered in this theater. Their engineering doctrine is based on European conditions, where roads are good and terrain is relatively gentle. Here, they face an entirely different challenge, one for which they are unprepared both materially and psychologically. Captain Kenji Watanabe, commander of the bunker line directly overlooking the primary crossing site, had raised a question about the possibility of aerial bridge construction or airborne operations. General Tanaka had dismissed these concerns with barely concealed contempt. The Americans lack the airlift capacity for a significant airborne operation in this sector, he had stated flatly. As for aerial bridge construction, such technology does not exist. We have consulted with our own aviation engineers, and they confirmed that no aircraft in the American inventory could transport bridge components of the required size and weight. The assembled officers had nodded their agreement. After all, Japanese military intelligence was renowned for its thoroughness, and the assessments provided by Tokyo. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Machine gun positions covered every trail, every fold in the ground, every possible avenue of advance. Anti-aircraft batteries protected against air attacks, while searchlights and flares ensured that any nighttime crossing attempt would be illuminated and destroyed. The confidence of the Japanese defenders was further bolstered by their assessment of Allied supply lines. The nearest American supply base was in Lado, India, connected to the front lines by a narrow, winding road that Japanese intelligence correctly identified as barely capable of supporting current operations. Any major offensive requiring heavy bridging equipment would, Japanese planners calculated, overwhelm this tenuous supply line and collapse of its own logistical weight long before reaching the Salween River. Major Ichiro Saito, the senior engineering officer responsible for demolishing all bridges in the sector, had submitted a detailed report to General Tanaka outlining the time required for Allied forces to construct various types of bridges across the Salween Gorge. Using standard engineering manuals and consulting with civilian experts, Saito had calculated that a pontoon bridge was impossible due to the current and depth. A suspension bridge would require specialized equipment and at least 6 weeks of construction time under ideal conditions. A conventional beam bridge, using the standard Bailey bridge system, would require transport of components weighing several hundred tons, assembly time of 3 to 4 weeks, and would be vulnerable to artillery fire throughout the construction process. These calculations assumed, of course, that the Americans would even attempt a crossing at the Salween. Many Japanese officers believed that the Allies would instead outflank the position by advancing through even more difficult terrain to the north or south, moves that Japanese intelligence assets would detect in advance and allow for appropriate redeployment of defensive forces. Either way, the Japanese command structure believed they held every advantage of terrain, preparation, and tactical acumen. On the evening of March 14th, Japanese observation posts reported increased Allied activity on the western bank of the Salween, including the movement of engineering equipment and what appeared to be preliminary reconnaissance of crossing sites. This activity provoked no particular alarm in the Japanese command bunker. Similar preparations had been observed before previous Allied probes, none of which had resulted in serious crossing attempts. Colonel Yamada ordered increased vigilance, but expressed confidence that any American attempt would provide Japanese gunners with excellent target practice. What the Japanese observers could not see, hidden in the dense jungle 3 miles from the river, was a convoy of over 200 trucks carrying components of a revolutionary bridging system that would render all of Japanese calculations and confidence utterly meaningless. The portable Bailey Bridge, a British invention that American engineers had adapted and mass-produced, represented a quantum leap in military engineering technology that Japanese intelligence had completely failed to detect or understand. The original Bailey Bridge had been designed by British civil engineer Donald Bailey in 1940 as a response to the British Army's need for a portable, rapidly deployable bridge system. The genius of Bailey's design lay in its modular construction, using standardized panels that could be carried by small trucks or even manhandled by troops, then assembled without heavy cranes or specialized equipment. Each panel weighed only 570 pounds, light enough for 6 men to carry, yet when properly assembled, the resulting bridge could support tanks and heavy vehicles. American engineers had encountered Bailey bridges during joint operations in North Africa and Italy and had immediately recognized their revolutionary potential. By 1943, American factories were producing Bailey Bridge components by the thousands, and engineer battalions were receiving intensive training in rapid bridge construction techniques. The system had been used successfully in Sicily and Italy, but Japanese intelligence focused primarily on the Pacific theater and largely cut off from detailed information about European operations had remained ignorant of this technological development. The 209th Engineer Combat Battalion, attached to the American Chinese forces preparing to cross the Salween, had been training for this operation for 3 months. Their commander, Lieutenant Colonel James Harrison, a former construction engineer from Pennsylvania, had personally supervised the training program that taught his men to assemble Bailey bridge spans in record time. His best teams could assemble a complete 120-foot span in under 8 hours, a feat that would have seemed impossible using conventional bridging techniques. But Harrison and his staff knew that 8 hours of assembly time would be far too long under direct enemy fire. Japanese artillery would destroy any bridge during conventional construction, regardless of how quickly American engineers worked. The solution to this problem represented another innovation that Japanese planners had never considered. Instead of assembling the bridge in place over the river, American engineers would construct complete sections in concealed positions behind the jungle, then move them forward on specially designed rollers and launch them across the gorge using a technique that resembled a horizontal drawbridge. On the night of March 15th, as Colonel Yamada slept confidently in his quarters, American and Chinese troops moved into position for an operation that would shatter every assumption Japanese defenders held about Allied engineering capabilities. The 209th Engineer Combat Battalion had spent the previous 2 days assembling 3 complete Bailey Bridge sections, each 140 feet long, in clearings carved from the jungle 2 miles from the river. These sections now rested on wheeled assemblies, ready to be moved forward under cover of darkness. Colonel Harrison had choreographed the operation with the precision of a symphony conductor. Artillery units were positioned to provide suppressive fire against Japanese bunkers. Smoke generators would create a dense screen across the gorge to blind enemy observers. Infantry units would provide close protection for the engineers. Medical teams stood ready to treat casualties. Every element had been rehearsed repeatedly, but Harrison knew that the success or failure of the operation would ultimately depend on whether his engineers could move and launch the bridge sections before Japanese artillery found the range and destroyed them. The irony of the situation would have been apparent to any neutral observer familiar with both sides' assessments and capabilities. Japanese confidence was built on calculations that were entirely accurate based on the information available to them, but fatally incomplete due to their ignorance of technological developments they had never imagined. American audacity was built on capabilities that existed but had never been tested under conditions as challenging as those presented by the Salween Gorge. Within hours, these 2 conflicting realities would collide with results that would shock the Japanese command structure and fundamentally alter the strategic situation in northern Burma. As dawn approached on March 16th, the stage was set for a demonstration of the danger inherent in underestimating an opponent's capacity for innovation and the fatal consequences of allowing strategic assumptions to harden into unquestioned dogma. Colonel Yamada would soon learn that the gorge he believed impassable was about to be spanned by technology he had never heard of, assembled using techniques he had never imagined, by engineers whose capabilities he had fatally misjudged. The first indication that something unprecedented was unfolding came at 4:45 hours on March 16th, when Sergeant Kiyoshi Taniguchi, manning Observation Post 7 on the eastern ridge, heard unusual mechanical sounds echoing from across the gorge. The sounds were different from the typical noises of Allied camps, a rhythmic grinding and clanking that suggested heavy equipment in motion.
Taniguchi reported the observation to his platoon leader, who dutifully passed it up the chain of command, but in the pre-dawn darkness with dense fog rising from the river below, visual confirmation was impossible.
Colonel Yamada, awakened by his aide at 051 hours, reviewed the reports with only mild interest. Allied forces frequently moved equipment at night to avoid Japanese air reconnaissance, and the sounds could indicate anything from supply convoy movements to repositioning of artillery. He ordered increased alertness along the defensive line, but saw no reason for immediate alarm. After all, his engineers had assured him that any serious bridge construction would be immediately obvious and would provide ample time for artillery response. At precisely 0530 hours, as the first gray light began to penetrate the morning fog, American artillery batteries opened fire with a barrage that surpassed anything the Japanese defenders had previously experienced in this sector. Over 80 guns, ranging from 105mm howitzers to 155mm long-range pieces, began pounding Japanese positions with carefully orchestrated fire. The bombardment was not merely random harassment, but a precisely calculated suppression mission designed to force Japanese gun crews into their bunkers and keep observation posts blinded by smoke and dust. Simultaneously, chemical warfare units activated smoke generators positioned at strategic points along the western ridge. Within minutes, a dense white cloud began rolling across the gorge, carried by the morning breeze directly toward Japanese positions. The smoke was far thicker and more persistent than anything the defenders had encountered before. A special formulation developed specifically for this operation that created an impenetrable screen even in the light wind conditions typical of morning hours in the gorge. Major Saito, the engineering officer, reached the forward command bunker at 045 hours and immediately sensed that something was different about this attack. The precision of the artillery fire, the density of the smoke screen, and the sheer volume of explosives being expended suggested that the Americans were preparing for something more significant than another probing attack. He recommended immediate counter-battery fire to disrupt whatever operation was being prepared, but the smoke made target identification impossible, and Japanese doctrine discouraged wasteful expenditure of ammunition against unseen targets. What Major Saito and his fellow officers could not see through the smoke and could barely hear over the thunder of artillery was an engineering operation that was unfolding with mechanical precision just 300 yards from their positions. The 209th Engineer Combat Battalion had moved into action the moment the bombardment began, and they were executing a plan that had been rehearsed dozens of times but never attempted under actual combat conditions against a prepared enemy. The first Bailey Bridge section, a complete span measuring 140 feet in length and weighing approximately 18 tons, was being wheeled forward on specially designed trolleys by teams of engineers working in carefully coordinated groups. The section had been pre-assembled in the jungle clearing, every bolt tightened, every connection verified, every structural element tested. Now it was being moved toward the edge of the gorge at a pace that would have seemed impossibly fast to any observer familiar with conventional bridging operations. Lieutenant Robert Chen, a Chinese-American engineer from California who had studied civil engineering at Berkeley before the war, commanded the lead construction team. His responsibility was to position the first bridge section at the launching point and secure it to the rock face using heavy anchor bolts that had been drilled and set days earlier during nighttime operations that Japanese observers had dismissed as routine patrol activity. Chen worked with the calm precision of a man who knew that any error would doom not just the bridge but the entire offensive operation that depended on it. The launching mechanism for the Bailey Bridge sections represented another innovation that Japanese planners had never encountered or imagined. Instead of constructing the bridge outward from the bank, which would have required working under direct enemy fire for hours, American engineers had developed a roller system that allowed complete bridge sections to be pushed forward across the gorge, cantilevered out from the western bank until they spanned the entire distance. The technique was audacious, technically challenging, and absolutely dependent on precise calculations of weight distribution and structural stress. Colonel Harrison stood at the operations center, monitoring reports from multiple teams and coordinating the complex choreography of the assault.
He knew that the smokescreen would not last indefinitely, and that Japanese artillery, once it found the range, would make bridge construction impossible. Everything depended on speed, precision, and the element of surprise. His engineers had trained for months, but training against a stopwatch was vastly different from executing under enemy fire with lives and strategic objectives hanging in the balance. At 0610 hours, the first bridge section reached the launching point. Chen's team immediately began the process of securing it to the anchor points and preparing the roller mechanism for the push across the gorge. This was the most technically demanding phase of the operation, requiring perfect alignment and careful distribution of forces to prevent the cantilevered section from twisting or collapsing under its own weight. The mathematics involved were complex, but American engineers had done the calculations repeatedly and had built safety factors into every aspect of the design. The smokescreen continued to blanket the gorge, though occasional gaps allowed Japanese observers brief glimpses of shadowy activity on the western bank. These fragmentary observations were reported to command posts, where officers tried to piece together a coherent picture of what the Americans were attempting. The consensus remained that no serious bridge construction could be accomplished under current conditions, and that the Allied activity was likely preparation for an infantry assault using rope bridges or similar primitive crossing methods. This assessment was reinforced by Japanese military doctrine, which held that modern bridges required heavy equipment, extended construction time, and could not be built under direct fire. Everything in Japanese experience and training supported this conclusion, and no intelligence reports had suggested that the Americans possessed any technology that would challenge these assumptions. It was precisely this confidence in their own doctrinal understanding that was about to exact a devastating price. At 0625 hours, Chen signaled that the first bridge section was ready for launching. Harrison gave the order, and teams of engineers began the carefully coordinated push that would send 18 tons of steel girders and panels sliding out across empty space above the churning river 200 feet below. The roller system worked exactly as designed, the bridge section moving forward smoothly, its weight distributed across multiple support points that prevented any single element from being overstressed. Japanese observers, catching glimpses through thinning smoke, reported seeing what appeared to be a large structure extending from the western bank. But the reports were confused and contradictory. Some observers thought they were seeing a crane or derrick. Others believed it might be a communications tower. None suggested it was a bridge because the speed at which it was appearing made such an interpretation seem impossible. Bridges, in Japanese experience, were built gradually over days or weeks, not thrust across chasms in minutes. The first section reached the midpoint of the gorge at 0632 hours, cantilevered out into space with nothing beneath it but air and river. This was the moment of maximum structural stress, when the entire weight of the section was supported only by the western anchor points and the integrity of the Bailey panels themselves. Chen watched his stress gauges carefully, monitoring for any indication that the structure was beginning to fail. The mathematics involved were complex, but American engineers had done the calculations repeatedly and had built safety factors into every aspect of the design. The smokescreen continued to blanket the gorge, though occasional gaps allowed Japanese observers brief glimpses of shadowy activity on the western bank. These fragmentary observations were reported to command posts, where officers tried to piece together a coherent picture of what the Americans were attempting. The consensus remained that no serious bridge construction could be accomplished under current conditions, and that the Allied activity was likely preparation for an infantry assault using rope bridges or similar primitive crossing methods. This assessment was reinforced by Japanese military doctrine, which held that modern bridges required heavy equipment, extended construction time, and could not be built under direct fire. Everything in Japanese experience and training supported this conclusion, and no intelligence reports had suggested that the Americans possessed any technology that would challenge these assumptions. It was precisely this confidence in their own doctrinal understanding that was about to exact a devastating price. At 0625 hours, Chen signaled that the first bridge section was ready for launching. Harrison gave the order, and teams of engineers began the carefully coordinated push that would send 18 tons of steel girders and panels sliding out across empty space above the churning river 200 feet below. The roller system worked exactly as designed, the bridge section moving smoothly, its weight distributed across multiple support points that prevented any single element from being overstressed. Japanese observers, catching glimpses through thinning smoke, reported seeing what appeared to be a large structure extending from the western bank. But the reports were confused and contradictory. Some observers thought they were seeing a crane or derrick. Others believed it might be a communications tower. None suggested it was a bridge because the speed at which it was appearing made such an interpretation seem impossible. Bridges, in Japanese experience, were built gradually over days or weeks, not thrust across chasms in minutes. The first section reached the midpoint of the gorge at 0632 hours, cantilevered out into space with nothing beneath it but air and river. This was the moment of maximum structural stress, when the entire weight of the section was supported only by the western anchor points and the integrity of the Bailey panels themselves. Chen watched his stress gauges carefully, monitoring for any indication that the structure was beginning to fail.
The numbers remained within acceptable parameters, testament to the engineering genius of Donald Bailey and the quality of American manufacturing. At 6065 hours, as Japanese artillery finally began to find range through the dissipating smoke, the first bridge section made contact with the eastern bank. The moment was both triumph and critical vulnerability, as engineers now had to secure the section to pre-positioned anchor points while under increasingly accurate enemy fire. Corporal Michael Kowalski, a steelworker from Pittsburgh in civilian life, led the team that rushed forward to make the critical connections. Artillery shells were exploding around them, sending shrapnel and rock fragments through the air. But Kowalski and his team worked with the focused intensity of men who understood that failure meant not just personal death, but strategic disaster. The eastern anchor connections were completed at 6051 hours, and Chen immediately signaled for the second bridge section to begin its journey across the gorge. The plan called for 3 sections to be launched in succession, creating a complete crossing capable of supporting heavy vehicles and armor. But as the smoke continued to thin and Japanese gunners began to understand what they were witnessing, the fire intensified dramatically. Major Saito, observing from Bunker Complex 3, finally grasped the full magnitude of what was occurring. The Americans were not building a bridge in the conventional sense. They were launching pre-assembled sections across the gorge using some kind of advanced modular system that Japanese intelligence had never reported and the Japanese engineers had never imagined existed. He immediately ordered every available gun to target the bridge and the western launch point, and he dispatched urgent messages to division headquarters describing the unprecedented American capability. Colonel Yamada, receiving Saito's report at 6058 hours, and experienced a moment of profound cognitive dissonance. What Saito was describing seemed technically impossible, based on everything Yamada understood about engineering and logistics. Yet the reports were consistent, and he could now hear the distinctive sound of heavy vehicles moving across metal, a sound that could only mean one thing. The Americans had somehow accomplished what his experts had calculated would require weeks, and they had done it in little more than an hour. The second bridge section completed its crossing at 7:15 hours, and the third section was already in motion. Japanese artillery fire was now falling heavily on both the bridge itself and the approaches, but the Bailey Bridge's modular design meant that even direct hits, while damaging individual panels, did not necessarily collapse the entire structure. American engineers had anticipated this and had designed redundancy into every aspect of the system. Where a conventional bridge might fail catastrophically from a single hit, the Bailey Bridge could absorb damage and continue functioning. The psychological impact on Japanese defenders of watching the bridge materialize before their eyes was profound and demoralizing. Everything they had been told about American engineering limitations, everything their own experts had assured them about the impossibility of rapid bridge construction, was being contradicted by the evidence of their own senses. The Americans were not just crossing the river, they were doing so with a speed and efficiency that suggested technical capabilities far beyond what Japanese intelligence had credited them with possessing.
Private First Class Hiroshi Nakamura, manning a machine gun position with a direct view of the bridge, later wrote in his diary about the surreal quality of watching the structure extend across the gorge. "It was like watching a giant metal snake sliding across empty air," he recorded. "We fired everything we had at it, but it just kept coming. I realized in that moment that we had been lied to about American capabilities, and I wondered what else our commanders had been wrong about." The third bridge section locked into place at 7:32 hours, completing the span and creating a continuous roadway across the Salween Gorge. American engineers immediately began reinforcing connections and installing decking panels, while infantry units established defensive perimeters on both banks. Japanese artillery continued to pound the structure, and several panels were damaged or destroyed, but repair teams were already replacing damaged sections with spare components that had been pre-positioned for exactly this contingency. At 7:45 hours, barely 2 hours after the operation had begun, the first American tanks rolled onto the bridge. The sight of 30-ton Sherman tanks crossing a structure that had not existed at dawn was so shocking to Japanese observers that some initially refused to believe what they were seeing, insisting it must be some kind of elaborate deception. But the grinding roar of tank engines and the distinctive clank of treads on steel could not be denied or explained away. General Tanaka, receiving reports at his headquarters 5 miles from the river, struggled to process the implications of what had occurred. His entire defensive strategy had been predicated on the assumption that the Salween Gorge was effectively uncrossable, except by light infantry using primitive methods. That assumption had now been demolished as thoroughly as if the gorge itself had been filled in. American armor and mechanized infantry were pouring across the bridge, and the carefully prepared defensive positions on the eastern bank were being outflanked and overwhelmed by forces that should not have been able to reach them. The subsequent collapse of Japanese defenses along the Salween was not immediate, but it was inexorable. Positions that had been designed to repel infantry assaults were ill-suited to defense against armor supported by overwhelming artillery fire. Supply lines that had been considered secure because they were beyond the river were now exposed to American raids. Reinforcements that would have required weeks to arrive by the remaining roads now faced an enemy already established in positions that Japanese planning had assumed would remain inaccessible. By nightfall on March 16th, American and Chinese forces had established a bridgehead 3 miles deep on the eastern side of the Salween, and the Bailey Bridge, despite continuous Japanese artillery harassment, remained functional and was being used to transport additional forces and supplies across the gorge. Japanese commanders, scrambling to organize counterattacks, found their options limited by the speed with which American forces had exploited their breakthrough. Colonel Yamada, overseeing the evacuation of wounded from forward positions, confronted the bitter reality that his confident predictions of American limitations had been catastrophically wrong. The bridge that his engineers had calculated would require weeks to construct had been assembled in hours. The engineering capabilities that his intelligence officers had dismissed as primitive and inflexible have proven adaptable and sophisticated. The Americans he had characterized as soft and dependent on comfort had worked under heavy fire with determination and skill. The strategic consequences extended far beyond the immediate tactical situation at the Salween. Japanese defensive planning throughout Burma had been based on similar assumptions about Allied engineering limitations and the defensive advantages provided by rivers, gorges, and demolished bridges.
If the Americans possessed portable bridging technology capable of spanning the Salween in hours, then every Japanese defensive line, based on river barriers, was potentially vulnerable. The entire strategic framework for defending Burma needed to be reconsidered. Lieutenant Colonel Matsumoto, the intelligence officer who had confidently assured his superiors that the Americans lacked rapid bridging capabilities, found himself preparing a report that amounted to a confession of comprehensive intelligence failure. The Bailey Bridge system had been operational in other theaters for months, but Japanese intelligence collection and analysis had failed to identify it, assess its capabilities, or warn field commanders of its existence. This failure reflected deeper problems in Japanese intelligence methodology, including over-reliance on technical assumptions and insufficient attention to Allied technological innovation. In the days following the crossing, as American forces continued to exploit their bridgehead and Japanese units retreated towards secondary defensive positions, survivors from the Salween sector struggled to explain how such a comprehensive defeat had occurred. The explanations typically focused on specific tactical failures, inadequate artillery support, or insufficient reserves. But beneath these tactical analyses lay a more uncomfortable truth that few were willing to articulate openly. The Japanese military establishment had fundamentally underestimated American engineering capabilities and had paid a devastating price for that underestimation. Major Saito, who survived the battle and was reassigned to a staff position in Rangoon, spent considerable time analyzing what had gone wrong. In a confidential report submitted to Army headquarters, he outlined the technical specifications of the Bailey Bridge system based on observations and captured American engineering manuals. His report concluded with a stark warning. The enemy possesses engineering technology and organizational methods superior to our own in several critical areas. We must abandon the assumption that American technical capabilities are inferior and instead plan on the basis that they may possess significant advantages in industrial production, logistics, and engineering innovation. This report was filed and largely ignored. The admission that American technical capabilities might exceed Japanese equivalents contradicted too many cherished assumptions and threatened too many reputations. It was more comfortable to attribute the defeat at the Salween to specific tactical errors or bad luck than to confront the systemic intelligence and doctrinal failures that had made the defeat possible. The engineers of the 209th, who had executed the bridge construction under fire, received commendations and recognition for their achievement, but for Lieutenant Colonel Harrison and his officers, the victory was tempered by the casualties sustained during the operation. 18 engineers had been killed and 47 wounded during the construction and initial defense of the bridge. These losses were relatively light compared to what might have been expected from a conventional river assault, but each casualty represented a trained specialist whose skills and experience could not be easily replaced. Lieutenant Chen, reflecting on the operation years later, emphasized the role of thorough preparation and realistic training in the success of the mission. "We spent 3 months learning every aspect of that bridge system," he recalled in an interview. "We could assemble sections blindfolded. We had practiced the launch sequence until it was automatic. When we executed under fire, we were not improvising. We were implementing a plan that had been refined through countless rehearsals. That preparation made the difference between success and catastrophic failure." The Bailey Bridge across the Salween remained in operation for the duration of the Burma campaign, and its existence fundamentally altered the strategic calculations of both sides. Japanese forces could no longer rely on river barriers to channelize and delay Allied advances. Every demolished bridge was now merely a temporary inconvenience rather than a permanent obstacle. The strategic flexibility this provided to Allied commanders was immense and contributed significantly to the eventual successful offensive that would reclaim Burma. For the American military establishment, the success at the Salween validated decisions made years earlier to invest in portable bridging technology and to train engineers to world-class standards. The Bailey Bridge system, combined with American industrial capacity to produce components by the thousands and American engineering skill to deploy them rapidly, represented a decisive technical advantage that Japanese forces never successfully countered. The contrast between American and Japanese approaches to military engineering reflected deeper differences in industrial philosophy and organizational culture. American engineers were encouraged to innovate, to question established methods, and to seek technical solutions to tactical problems. Japanese engineering, while capable of impressive achievements, was more constrained by doctrine and tradition. When confronted with a novel problem like the Salween Gorge, American engineers sought novel solutions. Japanese engineers, operating within more rigid doctrinal frameworks, relied on established methods and underestimated their opponents' capacity for innovation. As American forces pushed deeper into Burma in the months following the Salween crossing, they encountered numerous other river barriers and demolished bridges. In each case, Bailey Bridge sections were deployed, often within hours of reaching an obstacle. What would have been campaign-ending obstacles in earlier wars became minor delays.
The cumulative effect of this engineering advantage was to accelerate the Allied advance and to place Japanese defenders under continuous pressure from which they could never fully recover. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.